All right. Yeah, today we have Anyla with us, so thank you very much for coming. And our today's talk is a bit about your or one of your very recent publications, which is on working memory and important cognitive functions, but also a very interesting and new technique about brain stimulation. So this transcutaneous vagus nerve stimulation. So in a nutshell, what is your study about?
Yeah, and the last years there has been a growing interest in non-invasive brain stimulation techniques and how they can enhance or improve our cognitive functions. One of the prominent ones is transcutaneous vagus nerve stimulation, transcutaneous meaning through skin. It's a novel technique that influences vagus nerve, which is the largest cranial nerve in our body, connecting many organs and also the brain and also the heart, between others. So TVNS looks like this. It's a small portable device. It has this small electrode which induces small electrical currents. Usually it is positioned in the ear. So this way a vagus nerve is stimulated, and by being stimulated it sends signals to our brain and enhances different neurotransmitters like GABA and noradrenaline, which are very important for our cognitive functions.
All right, so what you basically do is that there seems to be a lot of research already going on into potential mechanisms, how atVNS is working, but what's the specific contribution of your work? What does it set apart from others?
Yes, well, in this study, we aim to investigate how TVNS, this device, is influencing working memory. Working memory is one of our crucial cognitive functions that allows us to update and manipulate information that we encounter every day. This is especially important in today's digital age, where we get all the source of information from smartphones, from our social media. So our working memory is particularly high in demand, and this is why what we aimed to investigate was how TVNS influences working memory and its associated neurophysiological mechanisms. What we found was that atVNS helps the brain or improves the ability of the brain to hold on to information by improving this process called information maintenance process of working memory.
All right, so there seems to be a very specific effect of this atVNS to, let's say, keep information in working memory and not that much to, let's say, let new information enter the working memory. So it's really important to, let's say, stick to a goal, to stick to a plan that's being held in working memory. But how did you find that out?
Yes, well, we used EEG brain recordings to see how TVNS is influencing the electrical brain activity while being stimulated and while doing a working memory task. So we also use the pupil diameter tracking. The pupil diameter tracking is very important because it is said that it reflects how noradrenaline changes, which is a very important neurotransmitter influenced by TVNS. What we found in this study is that actually there were no changes in the noradrenaline levels. Therefore, we assume that GABA is the underlying mechanism which is responsible for the changes that we see here.
So you can really, let's say, put apart or provide some new insights, at least when it gets to working memory, that for here, for example, the GABAergic system is a bit of more important. I mean, okay, there's lots of research going on in working memory, there's lots of research going on in atVNS, and you connect these, let's say, different lines of research, but what's the added value behind?
Yes, well, we already know that there are certain neurotransmitters that are involved in working memory. What we add or what we see here is that working memory needs to be dynamically controlled into what is being led and what is not being led into working memory, and how this information stays and for how long it stays before getting replaced. And it is this, especially this dynamic, that we were able to modulate. And this is important and can give us more information, and also it challenges the previous assumptions onto which are the primary neurotransmitters underlying these changes that we see through TVNS.
So in this case, it would be, let's say, it would more go into the direction that it is not that much the norepinephrine system. However, this is only then the case according to your study for working memory processes. For other cognitive functions, this may well be the case, maybe also in other populations that you are investigating. And this is, I think, a very important point, because I would think that having these brain stimulation processes affecting cognitive functions will have some important implication when it gets to clinics and also other things, right?
Of course, of course. Brain stimulation techniques, especially the non-invasive ones, are very important and offer the unique advantage over correlational methods. By directly activating or manipulating the brain activity, we see how a behavior and cognition changes, and we are able to establish these causal relationships between cognitive functions, functional brain anatomy regions, and also cognitive behavior and how it translates to it. Secondly, it is important because it can help develop treatments for people who have memory impairments, like develop new treatment strategies, and but not only, because it can also be used in settings where people just want to optimize their working memory or their cognitive skills, not necessarily just the impaired ones, but the healthy ones that want to optimize their cognitive performance and so on.
All right. I mean, this let's say brain optimization topic is a special one, so I'm not that much a big fan of that. But I would see definitely a very strong advantage of using these techniques maybe in, let's say, developmental or neurodevelopmental disorders like ADHD, which are characterized by deficits in the norepinephrine system functioning, but also other important disorders, to help them getting rid of their working memory problems, which I think would be a very important step to go.
For sure.
And of course, more research needs to be done.
For sure. It's interesting to see how this would help and how it connects different areas of science, like medicine, psychology, neuroscience, and so on.
Yeah, this is really important. Yeah, thank you very much for sharing your thoughts. It was very intriguing to hear these findings, and thank you very much for watching us. Goodbye.
Ja.